Hello student, how are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class I'll teach you the fluid mechanics in one shot, part 2. Today's topic is viscosity, surface tension and Bernoulli's theorem. Bernoulli's theorem. First, I consider just viscosity. What is suppose a liquid contains in a container. Liquid contains in a container. Now a force, external force, is applied on the surface of the liquid. External force is applied on the surface of the liquid. So that every liquid layer now opposes the motion of the surface layer. So first the surface of the liquid, surface of the upper liquid try to move under external force, and the surface layer below that surface, the surface layer which is below that surface try to oppose the motion of the liquid layer, so the friction force by the liquid is called viscosity. Friction force by liquid layer is viscous force. So what is the viscous force? Viscous force is the friction force when relative motion starts between two liquid layers. Friction force exerted by the liquid layer when relative motion starts between two liquid layers. This is the viscous force. And when an external force applied tangentially, here this force is external force applied tangentially on the liquid surface. So when an external force applied tangentially on the liquid surface, then the surface layer just below that surface try to oppose the motion of the upper surface. So that is called viscous force. A V depends. Viscous force is proportional to dV by dx into area. So when Fv is equal to then eta A dV by dx. This is the formula. So viscous force equal to eta A dV dx. What is eta? Eta equal to coefficient of viscosity, depends upon the nature of the liquid. Coefficient of viscosity. A is area of the liquid surface, and dV. What is dV? If the upper liquid moves with velocity v and the distance between two layers is dx, so the lower surface, the surface which is at a distance dx from the upper surface, moves with velocity v minus dv, and this surface moves with v minus 2 dv. So velocity gradually decrease and the velocity at the bottom will be zero. So gradually velocity decreases and at the bottom surface velocity is zero. So dv is velocity difference between two liquid surface separated by distance dx. So dv equal to what? Dv equal to velocity difference between two liquid surface separated by distance dx. So this is the main formula. Fv equal to eta A dV by dx. What is dV? dV is equal to velocity difference between two liquid layers separated by distance dx. dx equal to distance between two liquid layers. A equal to surface area of liquid surface. A equal to and eta equal to coefficient of viscosity. So this is the main formula. Now viscous force, and this is equal to external force because F and FB balance each other such that the liquid layer moves with constant velocity. So this is external force and this is equal to viscous force. The formula of viscous force will be this. Why external force equal to viscous force? Because the liquid layer moves with constant velocity. We consider the liquid layer moves with constant velocity. That's why this equal to this. So coefficient of viscosity, eta, its unit is F equal to A into dV by dx eta. So eta equal to F into dx A into dV. So the dimension is ml to the power minus 2. Dimension of force is this. Dx is length. Area is L square. dV is L by T. This. So L cancel. L 1 L cancel. So m L to the power minus 1. So the dimension of eta equal to this and dimension of this is equal to this and unit is Newton. This is meter square and meter square and this is meter per second. That is Newton second meter minus Newton second per meter square. Newton second per meter square. Newton second per meter square. Now this is Pascal second. We know 1 Newton per meter square is denoted by Pascal second. And SI unit is decapoise. SI unit of viscosity is decapoise. Viscous force on the spherical body, spherical ball. Suppose this is a spherical ball. When the spherical ball moves with velocity v, then viscous force act. Viscous force, the formula is viscous force equal to 6 pi eta r v. This is the formula of viscous force acting on the spherical ball, where eta equal to coefficient of viscosity, r is radius of the sphere, and v is velocity. So 6 pi eta r v is the viscous force acting on spherical ball, acting on when it moves with velocity v in the liquid of coefficient of viscosity eta. Now what is the terminal velocity when a spherical ball moves through a liquid? When a spherical moves through a liquid, then first it moves with acceleration. Now as it has acceleration, so its velocity increases with time. The ball has an acceleration. As it has acceleration, then its velocity increases with time. So after a certain time, when viscous force acts upward, this is viscous force, and buoyancy force act upward direction and weight act downward. After certain time, initially mg greater than b plus ab. At a time when mg balances the buoyancy force plus viscous force, this constant, mg and b constant, but ab varies, viscous force varies. So at the first mg greater than this. Now ab gradually increases as velocity increases. When b plus ab balance is equal to the weight, when b plus ab is equal to the weight, then the body has gained a terminal velocity. The spherical ball attained a constant velocity, which is called terminal velocity. When b plus ab is equal to mg, then spherical ball attained a constant velocity, which is called terminal velocity. So for terminal velocity we equate this equation. Now What is buoyancy force? Buoyancy force equal to volume density of the liquid into g. And what is viscous force? 6 pi eta r vt equal to weight volume into density of the solid. Suppose spherical ball whose density is ds, spherical vds into g. Now from this equation we get vt 6 pi eta r vt equal to v into g ds minus dl. So vt equal to pi r cube into ds minus dl by 6 pi eta r. So if we simplify this r square, it becomes 2 by 9 r square g ds minus dl by eta. So the formula of terminal velocity is this. If you cannot remember this formula, then this equation. Now you have to memorize if this term. Now if these terms these are constant, then we can say that beta is proportional to r square. That is r square means if all the terms this and medium remain same, then viscous force, then the terminal velocity is proportional to square of the radius. Velocity versus time. If we draw the graph velocity versus time of a spherical ball through the liquid, if we draw the velocity versus time of the spherical ball through the liquid, then the graph will be this shape, this way. So this is constant after certain time, and that velocity is called terminal velocity vt. So if we draw the graph of velocity versus time of a spherical ball, then the graph will be this way. Now this is constant velocity, so this is called terminal velocity. The problems related to terminal velocity. So problem 1, suppose two balls of same radius rr. Suppose two balls of same radius moves with velocity v moves with same velocity. Two balls moves with same velocity in a liquid. Now after certain time two balls combine. So if the two balls combined, now what is the velocity of this combined body? So what is the answer? If two identical ball has the terminal velocity v, after combination what is the terminal velocity of the combined ball? Liquid material all are same. We show that v equal to k r square. K is a constant. K into r square. R is radius. So what is the radius of the combined ball? You have to find. Now volume v equal to 4/3 pi r cube. Now here the volume will be 2v. So if this volume is v, then this volume will be 2v. So 2v equal to r dash whole cube. Now this radius is r dash. So 2 into v equal to, cancel this and this. So r dash equal to r into 2 to the power 1/3. R dash equal to r into 2 to the power 1/3. Okay, r dash equal to r into this. We got this. Now terminal velocity v is given. This is given. So v equal to k r square. Now v dash, this is unknown. V dash equal to velocity of the combined v V dash equal to terminal velocity of the combined body. So V dash equal to K into R dash square. Dash by D equal to K R dash whole square by K R square. Cancel this. So V dash equal to V into R dash by R whole square. So R dash by R equal to the power R dash by R equal to the power 1/3 whole square. So V dash equal to V into 2 to the power 2/3. V dash equal to V into R dash by R equal to the power 1/3 whole square. So this is the result. This is the answer. Terminal velocity of a iron ball of mass M is V. What is the terminal velocity of iron ball of mass 27 m through the same liquid? The option is given 9V, 3V, V by 3, 9, V by 9. So this is the one problem. Problem is the terminal velocity of a iron ball of mass M is V. What is the terminal velocity of iron ball of mass 27 m through the same liquid? So what is the problem? Problem is, suppose liquid is same. Suppose a ball of mass M has velocity V. Now what is the velocity of a ball whose mass is 27 m? What is the terminal velocity of this? V dash. V dash equal to what? So this is iron, this is also iron. So material is same, liquid also same, just mass is different. Here mass is in 27 m. What is the velocity? What is the terminal velocity of this ball? What is the solution? Solution here, if the radius is r, if the radius of the ball is r and this radius is r dash, so what is the relation between r and r dash? We have to find relation between r and r dash. Now mass equal to volume into density. Suppose density iron, density of steel, density of iron is rho s, and now 27 m equal to volume. Suppose the radius is r dash, volume into density, rho s density. This is iron, so density remains same. Now divide this by this, okay. 27 equal to, if we cancel this divided this, that is r dash by r whole cube. Now r dash by r equal to 3, so r dash equal to 3r. We get this. Now so we know velocity equal to k r square and v dash equal to k r dash square. So v dash by v equal to r dash by r whole square. Now what is r dash by r? Equal to 3 square, that's 9. So v dash equal to 9v. So this is the answer. Okay, you understand? Next topic is surface tension. How surface tension is developed at the surface of the liquid? Suppose this is a liquid surface. Suppose this is a liquid surface. If we consider a molecule at the surface of the liquid and a molecule at the within the liquid. If we consider a molecule within the liquid and a molecule at the surface, what force act at this molecule? The force from all direction acts, because this molecule is surrounded by all other molecule. But here the force is directed in this way. this. Here is no molecule, so force is directed in this way. Now the resultant of this force will be in this direction, and the resultant of this resultant force acting on the molecule will be 0, because all the force cancel each other. Resultant force on the molecule is 0, but here the resultant force act in this direction, because this cancel this, and this resultant is this. So the resultant force act downward on the all molecules which are present at the surface of the liquid. And here this molecule is attached, because here a container surface and liquid molecule present a force of attraction act, which is called force of adhesive force. Fa equal to force acting between liquid and solid molecule. Here is a molecule of glass surface, molecule of container and molecule of liquid. So force of attraction between liquid and solid molecules is called Fa. Fa is adhesive force. So here a force act, and all the molecule has a downward force. So the shape of the surface behaves like this way. Now that is surface be extended. So surface be extended. As the surface be extended, then a tension act on the surface like this way. Suppose this is a string supported by two vertical wall. Now if a mass is attached at the middle of the string, then the string extended. So due to the extension, a tension act on the string. So the tension is developed when we extend a surface or a string. The tension is developed. So here liquid surface is extended, so a surface tension is developed. Now what is surface tension? If we put a string of length L and force act is F. Then force per unit length F by L is called surface tension. Surface tension is denoted by T. So F is force and L is length of object. Force by length equal to surface tension. So this is the formula. F equal to LT. Okay. Surface layer is extended because all the molecules of the surface has the downward force. So the surface is extended. So due to the extension, a surface tension is developed. Now surface tension is if a string is placed at the surface, then force act in this direction. Now force per length equal to surface tension. F equal to LT. L is the length of this string. L is the length of the string. Okay. What is the surface energy? Work done. Suppose this is a frame. This is the iron frame, and a liquid layer is present by string. This liquid layer is enclosed by string. Now the string is pulled in this direction, so the surface area is increased. Now what is the force? If the length is x and force is F and length is L, now what is the work done? Work done equal to work done by force equal to force into displacement. Now what is F? F equal to F by L. We know F by L equal to T. So F equal to LT into X. Now here it has two surface. It has two upward surface and downward surface. Up and down. Two surfaces present. So two surface is present, that is F by 2L equal to T. Two length is present, upside and downside. So if this is present upside and downside, two length is present. So F by 2L equal to T, 2LT, this T into 2LX. Now T into LX equal to what? First initially the string is present here, and this string is moved from this to this. So what is the extension of the surface? Extension of the surface area is 2lx, that is 2 into area is this 2a. So 2a is the area of the area increased. So 2lx 2a area increased. Area of liquid surface increased. So W by this is area of increase. So W work done by increased area del A equal to 2 T. Work done by del A equal to 2. So this is the important formula. We use this formula to solve the problem. Work done by increased area equal to surface tension. T means surface tension. Work done equal to surface energy. Surface energy per unit area equal to surface tension. W by del A equal to T. Suppose converted suppose a spherical ball is breaks and form n small balls, n number of small balls. So due to the breaking a heat is produced. Find the heat produced or find the heat produced due to breaking of sphere. So initially the radius is r. Suppose a spherical ball, suppose a water droplet, suppose this is a water droplet. A water droplet of radius r is break into n small water droplets. Find the heat produced due to breaking of water droplets. So what is the problem? What is the solution? A water droplet of radius r break into n small water droplets. What is the heat produced due to breaking of water droplets? The solution becomes solution is this. First, n small, this is radius r. So the volume, first we consider if the radius is r, now what is the now volume of the n small spherical droplets equal to volume of the big drops. So consider n into 4/3 pi r cube equal to 4/3 pi capital R cube. So this cancel. So r equal to r into n to the power 1/3. So this is the relation between r and smaller. Now increase in surface area in del A. Now increase in surface area del A del 4 pi r square. 4 pi r square equal to surface area of spherical ball minus 4 pi r square. This is the increase of surface area. So 4 pi n into r square minus r square. 4 pi n into smaller equal to r square by n to the power 2/3. So this is 4 pi r square into 1 minus 2 by 3. 1 minus 2 by 3 equal to n to the power 1/3 minus 1. So del A equal to this. Is given del A into T. So del A equal to 4 pi r square into T. Now work done equal to J into J, joule constant 4.2 joule per calorie. J into H equal to mass M, specific heat of the water droplet 1. This is value 1 into 10% increase. Theta is 10% increase. So theta equal to 4 pi r square into the power 1/3 minus 1 into T by J into mass of the ball. What is mass of the ball? If density of water droplet is 1, density of water equal to 1, then by mass equal to what? Volume 4/3 pi r cube into density. If we take in CBSE system, so this is density is 1. So 4 pi cancel, 4 pi cancel, r square r cancel. So answer is to this. So this is the answer. Theta is increase of temperature. This is increase of temperature. Increase of temperature equal to this. This is the answer. Okay. What done equal to J into H. W equal to, we know W equal to J into H. H is heat produced. Heat produced equal to ms theta, mass, specific heat is 1. Consider specific heat equal to 1 of the water. Theta is increase of temperature is theta. So we know the formula H equal to ms theta. So theta equal to this by this. Now mass of the water droplet, big droplet, volume into density. A liquid drops within a liquid drop, excess pressure within a liquid drop. Suppose this is a liquid drop, inside pressure is P1, inside has a pressure P1 and outside has a pressure P2, radius R, surface tension T. So P1 minus P2, excess pressure del P equal to P1 minus P2. This is called excess pressure and the formula will be 2T by R. T is surface tension, T equal to surface tension and R is radius of the water droplet, R is the radius of the liquid drops. So excess pressure equal to 2T by R. Now why it has a pressure? Why is inside the liquid drops, has more pressure than outside. If we consider this curvature, due to the surface tension, the tension is more. Due to the surface tension, pressure is more within the liquid. Because if we consider this curvature, then surface tension act in this way, T. So if we split this way, suppose this is theta. So T sin theta and T cos theta. T sin theta, T cos theta. Now T sin theta cancel each other. T cos theta acts within the liquid. T cos theta, that is a force act within this liquid. So force by area is pressure. So pressure is more than outside. So due to the curvature, extra force is produced at this place. So pressure is created at this place. Now if we consider this way, suppose if we consider this way, this curvature, and here P1, here P2, here pressure is P1, here pressure is P2, at which pressure is more, P1 or P2, P1 greater than P2, or P1 equal to P2, or P1 or P2 greater than P1, and P1 equal to 2P2, which one is correct? So here curvature is in this way, here tension, surface tension act in this way. Surface tension always act along the curvature of the surface. So T, now if we split T into two ways, so T sin theta acts, T cos theta balance, T sin theta act in this direction. So T sin theta act in this direction, that is if extra force act in this direction, so pressure is more at here. Now excess pressure equal to 2Tr by R for the liquid drops. So why, at which direction? So if the curvature is this way, then pressure inside the liquid is more than the outside, and if the curvature is in this way, that is in this way, then pressure is more in this side. Pressure is more in this side. So P1 greater than P2 here, P1 greater than P2 at here. Pressure within a soap bubble. Excess pressure within a soap bubble. So soap bubble has two soap bubbles. This is so suppose this radius is R, pressure P1, here is P2, here is a pressure P2, P3. So excess pressure is called P1 minus P3 equal to what? So here are two interface. air and liquid, liquid and air. Here two interface, air, liquid and air. So P1 minus P3, P1 minus P2 equal to 2T by R, and P2 minus P3 equal to 2T by R. Okay, now if we add P2 P2 cancel, so P1 minus P3, which is equal to excess pressure equal to 40 by R. So here formula is 40 by R. Excess pressure within a soap bubble equal to 40 by R. So due to when a small tube is insert, when a small tube is immersed in a liquid, then some liquid rise in this within the small tube. This rise is called the capillary height. This rise is called capillary height. So angle of contact is this way, this way. So the H is called capillary height. Here H is called capillary height. Now how H is formed? How H is formed? Due to surface tension, some liquid rises within the small tube. So here surface tension is in this direction, here surface tension is in this direction, and the surface angle, this is angle of contact, theta. So due to theta, T cos theta act in this direction, T sin theta act in this direction. So T sin theta and T cos theta. So T cos theta acts throughout the circumference of this liquid surface, circumference of the liquid surface. So total force act upward, total force acting upward equal to T cos theta into 2 pi r, which balance the weight of the rising portion, which balance the weight of the rising liquid. So this equal to 2 pi r equal to weight of raised liquid, which is equal to weight equal to volume into density pi r square into h into density d, volume into density into g. So from this we get h equal to 2t cos theta r dg. So this is the formula of capillary height for small tube, for small tube. That is, if r is small, then we can use this formula, and h into r equal to 2t cos theta by dg, constant. So as radius of the tube is increases, then height is decreases, because h into r equal to constant. Height, relation between height and radius of the circle is h into r equal to constant. As radius of this tube, as the radius of the tube increases, then height decreases. So this is the formula of capillary height. Now if tube is more, we neglect this weight of this portion. Here we neglect weight of this portion. Now if weight of this portion is considered, then height becomes the formula becomes this: if radius r is sufficient more, that if r is considered, then actual formula will be height of the capillary height. The formula of capillary height will be this: if r is sufficient more, or if it is given that r is considered, then height we use the formula of height is this, and theta, here theta is angle of contact. This angle is angle of contact. Two layers, two liquid surface is joint. Two liquid surface is joint. That is radius of two liquid drops. Here two liquid drops of different radius attached at a point. Now what is the radius of curvature of the interface? What is the radius of curvature of interface? That is this. Here radius of curvature of the interface, this will be different because here R2 less than R1, so pressure P2 greater than P1. So this pressure is more than this pressure. So due to this combination, at this point the interface will be this way. So here interface will be this way because P2 greater than P1, P2 greater than this. The liquid has more pressure than this liquid, so the interface will look like this way. So what is the radius of curvature of this phase? What is the radius of curvature of this interface? R. What is R? R is not R1, not R2. R is a different value. What is the value of R? Here pressure is P2 and here pressure is P1. So we know the excess pressure. Suppose air pressure is P. We know P1 minus P equal to 2T by R1 and P2 minus P equal to 2T by R2. Now if it has a pressure, inside pressure P2 and outside pressure P1, so P2 minus P1 equal to 2T by R different. Now P2 minus P1 we get from this equation. From this equation we get, if we subtract, then we get P1 minus P2 equal to 2T 1 by R1 minus 1 by R2. So now P1 minus P2 equal to what? 2T by R. This, okay. Now 2T cancel. So 1 by R equal to this. Liquid flow within a pipe. Liquid flow within a pipe. Now suppose, so liquid flow within a pipe. Here two types of flow is present: streamline flow and turbulent flow. If the velocity of the liquid is small, is less, if the velocity of the liquid is less than critical velocity. Critical velocity is a particular velocity. If the velocity of the liquid is less than the critical velocity, then the flow becomes streamline. So for streamline flow, velocity becomes less than critical velocity. Now critical velocity is a formula which is equal to n eta rho into d. Critical velocity of the liquid has a formula n eta rho d. What is n? N is Reynolds number, a number which define what will be the type of velocity, what will be the type of the flow of liquid through a pipe. The Reynolds number, eta is coefficient of viscosity of liquid. Rho is density of liquid, and d is diameter of the pipe. So critical velocity is defined by this, and so n equal to Reynolds number is defined by dc into rho d by eta. So this is Reynolds number. Now if Reynolds turbulent flow becomes when velocity greater than dc. Now the Reynolds number define a number which define what will be the type of flow through the tube. Now for streamline flow, velocity Reynolds number should less than 2100. Reynolds number should be less than 00 for streamline flow. And n greater than 2300 for for turbulent flow. Now what is the streamline flow? Streamline flow will be like this way. That is parallel flow. Streamline flow will be this way. Suppose a particle comes at this point, so velocity is in this direction. When the next particle comes at this point, his velocity will be in the same direction. So velocity of each particle, velocity of every particle when comes at this point will be in the same direction. That is the streamline flow. Velocity of every particle when comes at this point will be in the same direction. So this is the definition of streamline flow. That is, at each point, velocity of every particle of the fluid becomes is along the same direction. So the streamline flow look like this way. This is the streamline flow. And what is the turbulent flow? So the most movement of the every particle is random. It has no particular direction. Randomly flows. If the velocity becomes more, if the velocity of the liquid through a pipe becomes more, then the turbulent flow occurs. Now when we know that if a hole is present at the surface of the pipe, and if the turbulent flow occurs, then liquid comes out through the hole. But if the velocity becomes less, that is streamline flow. Then if hole is present at the liquid surface, then the fluid does not come outside the hole, because here flow is parallel, so it cannot come outside the hole. So when a turbulent flow is present, when velocity more, then liquid comes through the hole. But if the velocity is less, then if there is a hole present at the surface, then liquid does not come through the surface. Next topic is velocity of a flux. Now next topic is velocity of a flux. What is velocity of a flux? Suppose a container is, suppose some liquid contains in a container, and hole is made at here. Now the liquid emerges through the hole. Now the liquid emerges through the hole. So what is the velocity of the liquid through the hole? This is called velocity of a flux. Now how we calculate? If h is the height of the liquid and h is the depth of the that is at a depth h, hole is made. Now the liquid flow in this way. What is the velocity of a flux? If we consider this point and this point and apply Bernoulli's theorem between 2 points, suppose this is A, this is B, applying Bernoulli's theorem at point A and B, what we get? We get pressure at here, atmospheric pressure PA, here also atmospheric pressure PA by rho g plus H plus V. Here velocity becomes 0 because the liquid surface drops very slowly. So here we consider velocity 0. 0 is equal to PA by rho g plus here height from the ground is h minus small h plus velocity v square by 2g. So from this we get cancel this h. So v square equal to 2gh root over. So this is called velocity of a flux. H is depth of the hole. V equal to root over 2gh. This is called velocity of a flux. Now what is the condition for range? What is the range? From the range of this at which liquid flow, range equal to, we know this is horizontal projection, range equal to velocity into time, velocity equal to root over 2gh into time. What is time? Now this height is h minus h, so time taken t equal to root over twice of h minus h by g. This is the projectile motion. So time taken to counts the liquid from this height to ground level equal to this. So t equal to root over this. Now the formula becomes root over 2 into gg cancel. Formula becomes this. So this is the formula of range. Now condition for range to be maximum. Condition for range to be maximum. Condition for range to be maximum is that h equal to small a, capital H. So this is the condition for h to be maximum, because if we derivative this, then we get the condition h equal to, that is when the hole is at the midpoint, then range will be maximum. A hole is made here, quantity means whole area of this cross section is A, and area of the cross section is small a, height is h. So time taken to empty the tank is T equal to A by A to power 2h by g. This is the formula. You remember, this is the formula. A is area of this portion, small a is area of the hole, small a equal to area of hole, capital A is area of surface, area of tank, and h is height of the tank, height of tank. This is the formula. So when suppose this is the h is from the surface, from the ground. Suppose what is the time taken this to this side, h to h by 2 to fall the, what is, suppose h height, water of h height, suppose liquid of h height contains in the container. What is the time taken to fall the height h by 2 of the liquid? What is the time taken to fall the height h by 2? So first we calculate the time taken from to empty the whole tank to hold the tank is T1 equal to A by A to power 2h by g, 2h by g, and next we calculate the time taken for from height h by 2. So if we put h by 2, so this, now the time taken from this to this is total time to this time. So time taken equal time equal to T1 minus T2, which is equal to A by A this. Suppose what is the time taken to this height h by 2, time taken to this. First we calculate the whole time, that is to empty the tank, next to empty the tank when the liquid level is h by 2. Now subtract this. So this is the time taken to empty this level to this level. This is the time taken, required time. Suppose now what is the formula of rate of volume dV by dt through the pipe? If suppose this is a pressure, this end has pressure P1, liquid has a pressure P1, and this end has a liquid pressure P2. Now if L is the length of the pipe, now find the rate of flow through a horizontal pipe. So if we take the horizontal pipe of length L, so there must be a pressure gradient P1 P2, pressure gradient. So there must be a pressure gradient, that is P1 greater than P2, such that liquid flow from this to this. Now what is the rate of volume dV by dt through the pipe? This formula will be pi P1 minus P2 R to the power 4 by 8 beta L. This will be the formula. This is the formula of rate of flow, rate of volume, that is this is volume by time. This is the formula. P1 minus P2 is pressure, is called pressure gradient. R is radius of the pipe, beta coefficient of viscosity of the liquid, and L is length of the pipe. So this is a one formula, and another formula is gradually velocity decreases. So velocity will be like this way. suppose liquid flow through the pipe. Here we draw how the velocity of the liquid varies from the axis to the wall of the surface, wall of the pipe. How velocity of liquid varies from the axis to the wall of the pipe. So we know that velocity how velocity varies from this to this. The formula is velocity equal to L is length of the pipe. Here pressure P1 is P2 radius is R, and small r is variable. So formula is r square minus small r square. This is the formula of velocity at distance r from axis. From this is the axis, at a distance r from the axis, velocity of the liquid equal to this formula. Now from this formula we know that if r equal to 0, then velocity is maximum. So velocity is maximum at the axis of pipe, and velocity is 0 at the wall of pipe. That is when r equal to capital R, we measure r from the axis. When r equal to capital R, then velocity is 0. So at the wall velocity is 0, and at the axis velocity of the liquid is maximum. Student, this is the end of the class today. To get more important problems of NEET in fluid mechanics, watch my another video. Okay, thank you.